We have completed all the lessons in Chapter 6, and so now we want to kind of review all the different things we learned so that we can assess or take the test to see how much you remember, how much you can apply from what you learned over these last lessons. Okay, so I'm going to review the type of problems that we've gone over, and hopefully these seem familiar. If you want to, you could look at the problems I have here on the board. I'm going to be doing, there's about eight problems, 8 different types of problems I'm going to do. You could pause it, try it, and then you can see how I do it. That would give it a little extra way of reviewing, getting ready for the test. All right, so this first one is 7 to the third, and just asking for you to expand that out. What does 7 to the third mean? I don't want the answer. I don't want what value is it, but I want what does it mean? And so what it means is it's 7 times 7 times 7. It's 7 times 3 times, so 7, 7, 7. Okay? Now I could figure out what the value is by actually doing 7 times 7 times 7, but I'm not going to. I just wanted to see that you understand what 7 to the third means. Now here we have kind of the opposite. I have 6 times 6 times 6 times 6. How would I write that in exponential form? Well, it's going to be 6, and how many 6's do I have? To the 4th power. 6 to the 4th power. Okay, so we will have a section on exponential form, exponent form. Okay, let's go to 3. Value of expression. This is the one where you got to remember PEMDAS. Parentheses, exponents, multiplication and division, and then addition and subtraction. Okay, so we have this one problem here. 2 times 10 plus 5 to the second divided by 5. First thing I want to do is parentheses. I don't see any, so I can move on. Exponents. I see one. So I'm just going to bring it down just like this. 5 to the second power, or 5 squared, is 5 times 5, which is 25 divided by 5. Okay, so I'm done with my E. Now I go to multiplication and division, and I just want to start here and go that way. Okay, so multiplication and division. I'm starting here. I see I have a multiplication here. 2 times 10 is 20 plus 25. Oh, well, here I have a multiplication. I'm going to bring it down. 25 divided by 5. Then I don't get confused. So here I do this first. Then I did this. Now I'm still in the multiplication and division. I see one division here, so I'm going to do that. Bring that down. 25 divided by 5 is 5. Then bring everything else down. Now, multiplication division I'm done with. Now I go addition and subtraction. I only have this one addition, so it's 25, and that's my answer. But I followed PEMDAS. I followed the order of operations to go from here all the way to there. Okay? So I would, on your paper, I would write that on the side and just kind of remember that's what you want to do, PEMDAS. Please excuse my dear Aunt Sally, if you need that to remember. Okay, let's go to here. There will be some problems where you have a variable and you have what that variable represents, and then you plug them in and solve. Okay, so I have C divided by B. I know C is 10 divided by B. B is 2 minus A, 3 1/2. Okay. All right. Now I'm back to this order of operations. Once I plug them in, I know that I have to do my division first. 10 divided by 2 is 5 minus 3 1/2 equals. And you might have one like this, where you have a mixed number. Now, if I have this, I want to make them both into fractions. 5 is going to be 5 over 1, and this is going to be 3 times 2 is 6 plus 1, 7 halves. Okay? Now, subtraction and addition of fractions, I need a common denominator. So what can both of these go into is 2. So I'm going to make this into 2. So 1 times 2, and this times 2 is 10. Okay? Then I'm going to, since this is the same, 10 over 2 is the same as 5 over 1. Now I have 10 over 2 minus 7 over 2. Then I can just take it across. 7 minus 10. 10 minus 7 is 3. And 2, I bring across the denominator. So it's 3 over 2. I see that's an improper fraction. I know 2 can go into 3 one time, which leaves me these are going to be multiple choice, so it might say it this way, or it might say it that way. But you need to know both. Once you've done this, here's the improper fraction, here's the mixed number. Okay? There's going to be a few questions where it gives you some words, and you have to take those words, the verbal expression, and put it into an algebraic expression. So on this one, 20 miles less than Mr. Smoke drove. I know that I don't know how much that Mr. Smoke drove, so that's my variable. So I'm going to put S. S equals how much I drove. Okay. So if my variable S equals that, I'm 20 less than that. So I'm going to start with what I drove, minus 20. And there's my algebraic expression to represent this, these words right here. All right, we've done quite a few of those. Hopefully you're good there. Okay, you will have some work on properties, and the 4 properties that you need to know: commutative, and that could be addition or multiplication only. Commutative. So it's saying that 5 times 2 equals 2 times 5. And it's saying like 3 plus 7 equals 7 plus 3. Okay, you can go back and forth, either with multiplication or addition. Doesn't matter which order. If they're all multiplication, you're going to get the same answer, and same with addition. Okay, that's commutative. Associative tells me that if I have 5 plus 2 plus 3 equals 5 plus 2 plus 3, doesn't matter if I do that first or if I do that first. So whichever ones I associate with first, I'm still going to get the same answer because they're all addition. I could do this instead of addition. I could have that multiplication. So it's either addition or multiplication. If it's all the same, doesn't matter what you do first. Associative. You can change things, the order of things. Identity is pretty simple. In terms of multiplication, anything times 1 is going to equal that number. Okay? So 5 times 1, 5. 3 times 1, 3. Whatever you have there, times 1, it's going to be the number. And the other identity thing is with addition. Anything plus 0 is going to be the number. So 5 plus 0 is 5. 20 plus 0 is 20. Anything that you add to 0 is that number. Okay? So that's the identity. Distributive. We spent a lot of time on this. This is where you distribute something out. So like you have 2, 4 plus 3. So I could go 4 plus 3. I could add that together and then times it by 2. Or I could distribute this out. I'm going to distribute the 2 to the 4. 2 times 4 plus, and I'm going to distribute it to the 3. 2 times 3. So now I've used the distributive property to solve this. Okay. We'll do a little bit more with the distributive as we go here. We will have to solve, or you will have to solve some of these. If you have 8 parentheses 4y plus 2, you got to distribute it, okay? So 8 goes over to here, and 8 times 4y is 32y plus 8 times 2 is 16. So I've distributed this 8 to both parts of this one thing. So now I get this. Okay? All right. The last couple are simplifying each expression. Here's where we get into like terms. We just got done talking a lot about this. Like terms. If they don't have a variable, like two numbers don't have a variable, they're always like terms. Always. If two terms have a variable and it's the same variable, then they're like terms. The only time they're not like terms, if one has a variable and one doesn't, that's not like terms. Or if they both have variables and they're not the same. Okay? So to be like terms, you have to not have a variable, or you have to have the same variable. So let's see what we got here. I want to simplify this. And I see that I have this term here, this term here, this term here. I have three terms. It's an x, an x, and an x. They all have a variable, and they all have the same variable. They are all like terms. So now I can just go in order here. 5 plus 2 is 7. 7 plus 3 is 10x. I've made this so much simpler. So when I find out what x is, so if x is 3, I just do 10 times 3. Instead of having to do 5 times 3, 2 times 3, 3 times 3, add that to that to that. That's more complicated. This is a lot simpler. So I have simplified this into here. Okay? Let's do this one. Distributive property. So 3 times 2 is going to give me 6x plus 3 times 3y is 9y. All right, so I've got to be careful with my y's. They sometimes look like x's. So I look at my terms. I have this term and I have this term. 9x, 9y. They both have a variable, but is the variable the same? X, y. No, nothing is like. They are not like terms. So this right here is simplified version, or is the simplified expression to this. Okay, you can't go any simpler because you can't put these two terms together. Okay, so hopefully this has been helpful. And just if you know all of these types of things that I talked about, you'll be fine. These are some really important foundational things as we move forward into Chapter 7. All right, if you have any questions, come see me. I'd love to help you understand this even more.